Hi. Today we're going to be talking about how fish and other marine life can live at extreme deep sea pressures. Now, I'm sure we've all seen a picture of this guy, who's commonly known as a blobfish. The internet has unceremoniously, but not unfittingly, named him as Mr. Blobby. What some people may not know, though, is that in his natural habitat of up to 2,800 meters below the ocean's surface, he is not in fact swimming around in all his pink gelatinous glory, but instead looks quite like a relatively normal fish. Now, why is this? Well, most fish that live near the surface swim via the use of an organ called the swim bladder, which is an internal organ that's usually filled with oxygen or other gases. It allows fish to maintain their current depth without either floating or sinking, allowing the fish to expend their energy on other endeavors such as hunting their food. Back to Mr. Blobby. He looks so different above the surface because of the extreme pressure change he experienced being brought to above sea level, which caused him to become a bit squishy, to say the least. But as we've learned in this course, the deeper you travel into the ocean, the more pressure is exerted on you. At sea level, we experience a pressure of 1 atmosphere, which increases by an atmosphere for every 10 meters we go underwater. This means that the maximum depth, 2,800 meters, of the aforementioned blobfish, the pressure would be 280 atmospheres, aka 280 times the pressure at sea level. At this depth, our body, which is primarily composed of water, which is incompressible, would be a little crunched, but the main damage would be the air in our bodies, like in our lungs, being instantly squeezed out of us, resulting in near immediate death. This would also be a problem for most fish that have swim bladders, as the organ would also be severely crushed. Many deep-sea fish avoid this problem by simply not having any extra air in their body that would allow them to be compressed in the form of eliminating their swim bladder. At extreme depths, however, this adaptation isn't enough to stop a fish from being crushed on its own. Take, for example, the Hadal snailfish. This fish is the deepest known dwelling species of fish and gets its name from living up to 8,200 meters below sea level in the Hadal zone, the deepest level of the ocean. Unlike most species that live in the Hadal zone which have no bones, to cope with the pressure, the Hadal snailfish developed cartilage-based bones not unlike a shark, which are not easily crushed. Additionally, species that live on or near the surface of Earth need to maintain a constant and suitable intracranial pressure in their skulls, which is known as a closed skull. Structural integrity is unmaintainable at extreme pressures, so Hadal snailfish have also evolved to have an open skull. These adaptations, along with several others such as the development of molecules called piezolytes, which assist in the process of molecular bonds not being crushed, are what allow these remarkable fish to survive what others cannot. There are many different species that live in the ocean steppes, from worms to whales, but some of the most fascinating creatures are marine crustaceans. As we get deeper down into the oceans, many species exhibit what is known as deep-sea gigantism, which is the tendency for species to be much larger than their surface-dwelling cousins. Take, for example, the common isopod, colloquially known as roly-polies, woodlice, pillbugs, and many other names. The ones we find in our back garden are often only a centimeter long. A little-known fact about isopods is that they are actually crustaceans and breathe through gills on the underside of their body. Their aquatic cousins, shown in this photo, however, can reach sizes of up to 50 centimeters, 50 times as large as terrestrial isopods. This is due to a number of factors, but one of the reasons is that due to high pressure and low water temperature in the deep ocean, there is a much higher dissolved oxygen content into the water. The larger an organism is, the more oxygen it can use. This is the same reason why ancient insects were so much larger than the ones we see today, as seen in this photo of a giant isopod. Alright, and that ends the presentation. I hope you've learned a little about just how fascinating life deep under the surface is, and how so many creatures can survive in conditions so inhospitable to life. Thank you for watching.